Hey guys, for the last couple of lessons we've been working on graphing sine and cosine functions. Today we're going to look at what the graph of the tangent function looks like and then also do some transformations to the graph of the tangent function. So first thing I'm going to have us do is just use our unit circle to fill in the following values. So notice I'm doing some different angles than normal. So normally for the sine and cosine we did just from 0 to 2 pi. I'm actually going to have us do from negative pi over 2 all the way to 2 pi using our, excuse the cat, using our unit circle. There's a cat standing on my unit circle. Okay. All right, starting with negative pi over 2. So that would be like if we went backwards pi over 2. Now remember, the tangent value is technically the y divided by the x, y over x, because tangent is equal to the sine divided by the cosine. So if I did the y divided by the x here, I would get negative 1 over 0, which is undefined because you can't divide by 0. And then at negative pi over 4, that would be right here. So that would be like taking this numerator y value and dividing by this numerator y value. So that would be negative root 2 over positive root 2, which would simplify to negative 1. Okay. And then after that, at angle of 0, if I did the y divided by the x, that would be 0 over 1, which is just 0. And then I have pi over 4 right here. If I did this numerator y divided by this numerator of the x, that would be root 2 over root 2, which is positive 1. Excuse the chaos. Okay, and then at pi over 2, if I did the y divided by the x, I would have 1 over 0, which again is undefined. And then at 3 pi over 4, that's right here, that would be root 2 over negative root 2, which would simplify to negative 1. And then at an angle of pi, like 180 degrees, if I did the y over the x, I would have 0 over negative 1, which is 0. At 5 pi over 4, way over here, negative root 2 over negative root 2. That would simplify to a positive 1. At 3 pi over 2, so here's 1 pi over 2, here's 2 pi over 2, here's 3 pi over 2. That would be back to be the same tangent that it was at negative pi over 2, so that would be negative 1 over 0, which again is undefined. And then at 7 pi over 4, that would be the same as what it was at negative pi over 2, negative pi over 4. That would be negative root 2 over positive root 2, which is negative 1. And then all the way back around to 2 pi, that would be 0 over 1, which is just 0. So the part that I have in gray right here, this negative pi over 2 to pi over 2, these are what we actually use for our 5 key points for the tangent function. And that's different than what we use for sine and cosine. For sine and cosine, we used 0 to 2 pi, counting by pi over 2s. For tangent, we use negative pi over 2 to pi over 2, and we count by pi over 4. So we increase by pi over 4. So these are our 5 key points. And you'll see why these are the 5 key points in just a second when we put these on a graph, because these are the points that it takes to make one cycle of the tangent function. So what happens to the graph of pi over 2, excuse me, what happens to tangent at pi over 2 and 3 pi over 2? So at pi over 2 and at 3 pi over 2 and at negative pi over 2, it was actually undefined there. Undefined because you can't divide by 0. Which means that at those places, at negative pi over 2 and basically intervals of like basically every pi after that, if we go another pi and then if we go another pi, there's going to be vertical asymptotes there. Vertical asymptotes. And there's going to be vertical asymptotes every pi after that. Okay, so let's plot some points. So at negative pi over 2, we were undefined. So I'm going to put myself a vertical asymptote there. Okay, at negative pi over 4, which would be the halfway in between 0 and negative pi over 2, right here, we had a value of negative 1, which I'm going to label a couple of them. Okay, so y value of negative 1. Okay, and then at 0, we had a value of 0. Easy to do that one. And then at pi over 4, we had a value of 1. So pi over 4 is right here, halfway between 0 and pi over 2. Okay. And then at pi over 2 again, we're back at it being undefined, which means another vertical asymptote. Now, if we had done even more points, notice we only did the points that were like at the multiples of pi over 4s. But if we had done more than that, we would have gotten more accurate points here. But since we didn't do that, we can just kind of show you what that part of the graph looks like. It's a little something like this. And this is one cycle of the graph. One cycle of the graph. So the period on this, it's similar. It's not 2 pi like it was for sine and cosine. It's actually a period of just pi because it goes from negative pi over 2 to pi over 2. And this pattern repeats over and over and over on the tangent function. So every pi after pi over 2, it would have another vertical asymptote. Same thing over here. If you went backwards to negative 3 pi over 2, it would have another vertical asymptote. And this same pattern of where the points are also repeats. So if you did another cycle on this side, it would have a point at negative pi 0, here, here, and you could use those points to graph another cycle of it. Same thing here. Or have another cycle of it. And then at the little parts over here, the parts that you can't barely see, you wouldn't get the entire cycle. You would just kind of get like the little tail end of the cycle, which would just look something like this, but it would continue going that way. Same thing on this side. You would only see the tail end of it, so just this part, but you don't see the part that continues up to the right. So our think, pair, share questions. First question is, what do you think is the period? Remember, the period is the x distance it takes to make one cycle. So like I said earlier, it's not the same as sine and cosine. Sine and cosine's period is 2 pi. The period for this one is just pi, the x distance it takes to make one cycle. Goes from negative pi over 2 to pi over 2, which would be a period of pi. Negative pi over 2 to pi over 2 is a distance of pi. Okay, what do you think is the amplitude? Amplitude, remember that the definition of that was the distance between the midline and the highest point of the sine or cosine graph, or the midline and the lowest point of the sine or cosine graph. But if you look at this, tangent doesn't have a highest or lowest point. Its highest point is infinity. Its lowest point is negative infinity. So it would not have an amplitude. None. It does still often have a values, but the a value isn't what we call amplitude. The a value would just be a vertical stretch. Why? Because there's not a max height. There's no max height. There's no highest point or lowest point. What do you think is the range? Okay, the range, remember, is the lowest to the highest on a graph. The lowest, we have this arrow here going down, so our lowest would be negative infinity. And our highest, we also have arrows going up, so the range would be positive infinity going upwards, not including either of those. And then the domain is pretty tricky. The domain is very technical the way we would write it. I would not recommend writing it in interval notation because you would have to basically list out every interval from now and forever. I would list out the domain in set notation. So if you look, our domain is every single x except for these places where we have the vertical asymptotes. So for our domain, we would say x is a real number. Oh, we got cat scaling the wall. set notation. X is a real number, or remember that little E looking thing means in the set of, and then R means is a real number. Except for it's not every pi over 2. So every pi over 2 and multiples of pi over 2 separated by a distance of pi. So how we would say that is we would say except x is not pi over 2, okay, plus pi n. Okay, now this is a very fancy way of saying that the asymptotes are at pi over 2 plus intervals of pi. So basically it's saying, yes, there's one asymptote at pi over 2, but there's also another pi unit later. And this n could be 1, so it could be 1 pi later or 2 pi later. So this means multiples of pi. Multiples of pi, because the asymptotes are pi apart. A-S-Y-M. Multiples of pi because the asymptotes are pi apart. Okay, let's flip it over. Let's look at some transformations of the tangent function. We're going to do the transformations similar to how we did transformations with the sine and cosine. So our general form of tangent we've got on the top here, we've got the same A, B, C, D. Okay, where A on this one is not the amplitude, the A is the vertical stretch, but you have still an A. So amplitude, there is none, but we would say vertical stretch would be the absolute value of A. The period you calculate different than you do for sine and cosine. For sine and cosine, it's 2 pi divided by the absolute value of B. It's different because the period for tangent was only pi. It's a smaller period. So you would say pi divided by the absolute value of B. And then similar to what we were dealing with sine and cosine, you always want to make sure B is factored out. So we need this kind of like internal parentheses here to make sure that we've identified the correct C value, which is the phase shift. Okay, so there are going to be vertical asymptotes for the parent function, and those vertical asymptotes are at negative pi over 2 and pi over 2 for the parent, and multiples of pi after that. For the transformed function, though, you will have to figure out where the new ones are, and we can still do that using our tables like we did before. Doing a horizontal stretch or compress would be our B value here. It not only changes the period, but it does change the asymptotes when you stretch it horizontally or compress it horizontally, because the new graph will be wider or narrower. We can find the new asymptotes by multiplying the original asymptotes by the stretch or compress amounts, which again, we'll find that whenever we do our table for adjusting our x's and y's. I guess it should have been multiplying. There we go. Okay. Phase shifts, those are the left and right transformations. They do change the asymptotes. It'll cause the asymptotes to move left or right. It does move them all in the same amount, so you can find the new asymptotes by just adding or subtracting your shift to the original asymptotes. Adding or subtracting. And again, we will find that whenever we finish our table. And then a vertical stretch or compress, that would be our A value, because remember, there's no technical amplitude on these. The vertical stretch or compress, the A, doesn't really have any effect on the asymptotes. Have no effect on the asymptotes. It just causes the actual tangent part of the graph, this part of the graph, to be stretched out or squished down. Okay, so for each of these, we're gonna find A, which would be our vertical stretch. We're gonna find the period, and then we'll find the asymptotes and make a little graph out of it. So I'm gonna start by listing out my original parent function points for this one. My parent function points, and remember this is for the tangent graph, and it was different than what we did for sine and cosine. It's not 0 to 2 pi. This one is negative pi over 2 to pi over 2, counting by multiples of pi over 4. So the next one would be negative pi over 4, and then 0, and then positive pi over 4. And then remember to help me think about what it looks like on these. So instead of having to flip my paper over and just directly copy down the y values, I kind of like to just draw a little example of what it looks like. So the first one over here would be at -1, or actually the first one is undefined because we have an asymptote. So undefined. And then we have one at -1, and then the next one's at 0, and then the next one's at +1, and then the last one is undefined because we have another asymptote there. All right, thinking of about what our a value is, our vertical stretch. So this one you can actually see there is no a value. The a value is just 1. So it would not be stretched out or squished down at all. It would just have a normal amount of 1. The period is going to be 2 pi. No, the period is pi divided by the absolute value of b. So we have pi divided by the absolute value of b, which on this one is 1/2. And if we simplify that, pi divided by 1/2 becomes 2 pi. So this one would be more stretched out this way. And the asymptotes we'll figure out in just a second, because we're going to take our transformations and adjust our point values now. So remember, anything not inside the parentheses is going to affect the y values. So I'm not going to have any change to my y values here. I'm going to leave these just like they are. But for my x values, I'm going to take what's inside my parentheses, set it equal to a number sign, and then solve for x. This one only has one step to solve for x. It would just be times 2 times 2. So this is telling me what I need to do to my x's. I need to do 2 times those numbers. So all of my x's we're going to multiply by 2. And then remember the y's had no change. Okay, so filling out my new table of y's, we'll have this one's undefined, -1, 0, 1, undefined. Okay, negative pi over 2 times 2 would become negative pi. Okay. Negative pi over 4 times 2 would simplify and you'd get just negative pi over 2. Okay, and remember, like I showed you before, once you figure out the pattern for how the x's are changing, you can just follow that pattern for the rest of them. So if you look, you can actually see it's just increasing by pi over 2 each time. So if you add pi over 2 to this, you would get 0. If you add 0 to pi over 2, you would get pi over 2. And then if you add pi over 2 to this, you would get 2 pi over 2, and 2 pi over 2 is just pi. And you can find these same x's if you were to just do the calculations over here. Okay, so filling out my graph, remember we are just doing one cycle of the graph. So I can see I have a vertical asymptote at negative pi and pi on this one. So I'm going to just randomly put negative pi here. I'll put pi here. In the middle we'll have 0. For the y scale, we only need to go up to 1 and down to -1. And then we probably also want to label some pi over 2's. Pi over 2, negative pi over 2. Okay, so I'll have a vertical asymptote at negative pi because that's where it's undefined now. Another vertical asymptote at pi. Okay. And then let's see, at negative pi over 2, we're down at -1. We'll have a point at 0, 0, and a point at pi over 2, 1. And remember the tangent function, it's not a straight line, it kind of curves through here. So you can just draw in the curve. Okay. So to list out the asymptotes, there is an asymptote at pi and there's an asymptote at negative pi. These are a distance of 2 pi apart. Okay? And the reason that it's farther apart than what they were on the parent is because of this b value here. So for our asymptotes, we'll have to say that they're at pi plus every interval of 2 pi after that. So the next one would be at 3 pi. Because they are not increasing by pi, they're increasing by 2 pi each time. So plus 2 pi, and then we'll say times n. So that just means intervals of 2 pi. All right, second one. Okay, we have tangent equals x minus pi over 4. Talking about first the vertical stretch, the a value. The a value in this one again is just 1. Okay, so it's not going to be any more stretched out or squished down than the parent. The period on this one, again, we'll do pi divided by the absolute value of b, which you can, the b on this one is just 1. So pi divided by 1 would be just pi, which is the normal period, just like the parent function. And then we'll come back and fill in our asymptotes in a second. Again, I'm going to start by filling in my x's and y's from the parent function. It goes from negative pi over 2 to pi over 2, counting by intervals of pi over 4. So the next one would be negative pi over 4, and then 0, and then positive pi over 4, and then ending at pi over 2. Okay, and then remember what the y values look like. So there's a vertical asymptote, another vertical asymptote, and then there'll be some points in the middle here. So my first value here would be undefined because there's a vertical asymptote. The next one is at negative 1, and then at 0, and then at positive 1, and then we end the cycle with another vertical asymptote, so another undefined. Okay, so looking at what I need to do for this graph, again, there are no numbers that would affect the y values because there's no numbers outside the parentheses. I just have this one inside the parentheses that will affect my x values. And I'm going to do the same thing I did on the last one. I'm going to take what's inside the parentheses, set it equal to a number sign, and then we'll solve this for x. So just like the last one, this one only has one step to solve for x. That would be to add pi over 4. So that's telling me what I need to do to my x's. Take those numbers and add pi over 4. And then there were no changes in our y's, so I'm going to leave those just like they are. Undefined, negative 1, 0, 1, undefined. And then let's adjust those x values. And again, once we figure out the pattern, we can just fill in what the pattern is and not have to worry about doing the actual calculations. Pi over 4 plus negative pi over 2, if you add those together, that would be negative pi over 4. And then pi over 4 plus negative pi over 4 is 0. Pi over 4 plus 0 is pi over 4. So you can actually see the pattern here. It's counting up by pi over 4s. So up pi over 4, up pi over 4. The next one would be add another pi over 4. So it would become 2 pi over 4. But 2 pi over 4 is just pi over 2. And then if I add another pi over 4 to 2 pi over 4, I would get 3 pi over 4. And then looking at how I need to adjust my scale, looks like we need to go by pi over 4s. So if we call this negative pi over 2, then this would be negative pi over 4, 0, positive pi over 4, positive pi over 2, and then 3 pi over 4. And then similar to the last one, the y values don't need any kind of change, so I'm just going to count them by 1s. And then I'm going to fill it in. Negative pi over 4 is where my first asymptote is. And then I have another asymptote at 3 pi over 4. This was just a phase shift, so this one is just one where it's moved to the right. Okay, and then we have a point at 0, negative 1. At pi over 4, we're at 0, and then at pi over 2, we're up at positive 1. We'll make our little curve through. Okay, and then looking at where my asymptotes are, I have one at negative pi over 4 and one at 3 pi over 4. It doesn't matter which one you list as like the starting one here. Like on this one, we could have listed negative pi plus 2 pi in. On this one, doesn't matter. I'm going to list this one on the left. X equals negative pi over 4 plus, these are only a distance of pi apart because they're always apart by however big the period is. So we'll say plus pi times n, meaning just like intervals of pi. So we start here, and then every interval of pi will have another one. Okay, and then one last one. Okay, so this one has an a and a b value. I can see my a value in the front, my b value in here. Notice none of these we've had to factor out the b, so that's kind of nice. That means the transformations are a little easier. My A value on this one would be absolute value of 2, which is 2. So this one's going to be more stretched out vertically. The period would be our pi divided by the absolute value of 3, which is just pi over 3. And then I'll come back and grab my vertical asymptotes in a second. So filling in my x values, remember for the tangent function it goes from negative pi over 2 to pi over 2. Counting by intervals of pi over 4. So you increase by pi over 4 each time. So the next one is negative pi over 4, and then 0, and then positive pi over 4, and then pi over 2. And then for the y values, remember we start with a vertical asymptote and end with a vertical asymptote. Undefined, undefined. And in between you have your little swoop where it starts down at negative 1, goes up to 0, and then goes up to positive 1. And looking at what we need to adjust for our values, I can see this number is outside the parentheses, so this one is going to affect our y values. So all of my y values, I'm going to need to do exactly what it says. I'm going to do 2 times my y values. 2 times y's. So on these, even though we have a vertical asymptote there, I'm still going to write it. It doesn't change it though. 2 times the asymptote doesn't change the asymptote. And then for the x values, this one is inside the parentheses, so I know it's going to change the x's. So we're going to take what's inside the parentheses, set it equal to a number sign, and then solve for x. So that would be my numbers divided by 3. Now since my numbers are mostly fractions, instead of saying divided by 3, I'm going to multiply by a third instead. Same thing mathematically, just easier to do with a fraction. Okay, my y should be pretty easy to fill out. 2 times my vertical asymptote is still undefined. 2 times negative 1 is negative 2. 2 times 0 is 0. 2 times 1 is 2. And then 2 times my vertical asymptote is still a vertical asymptote there. 1/3 times negative pi over 2 would be negative pi over 6. Okay. 1/3 times negative pi over 4 would be negative pi over 12. All right, anyone figure out the pattern yet? 1/3 times 0 is still 0. 1/3 times pi over 4 is pi over 12. It's actually increasing by pi over 12 each time. So if you add another pi over 12 to this, it would become 2 pi over 12. And 2 pi over 12 just reduces to pi over 6, which is what this one is. Okay, so this one, because of this 3 right here, it's actually very squished in. Okay, the period is very small. The period is only pi over 3. So to adjust our graph, let's see what we can do. I'm going to put, let's put pi way over here, negative pi way over here. And then if we split this into 6 sections, so this into 6 sections, this into 6 sections, those would be your pi over 6's. Split this into 6. Okay, so each of these little lines here would be a pi over 6. So this little guy right here is negative pi over 6. In between there is negative pi over 12. Did I do this one right? Negative pi over 12. I don't have room to label that, so I'm just going to remember that in between negative pi over 6 and 0 is negative pi over 12. And then obviously we have 0. I'm going to label my y-axis though. 1, 2, negative 1, negative 2. Okay, and then another pi over 12. Again, it would be in between the 0 and the pi over 6. Maybe I should have stretched out the scale, but also it's kind of nice to see how squished together this one is because the period's so small. Okay, so we're going to have our first asymptote at negative pi over 6. Okay, and then the other asymptote is at pi over 6. Okay, and then at negative pi over 12, which is in between 0 and negative pi over 6, we're down at negative 2. At 0, we're at 0. And then at pi over 12, which is halfway between 0 and pi over 6, we are at +2 up here. So this one's a teeny tiny squished together little tangent function. Okay, so for our asymptotes, we would say that they're we have one at -π/6, we have one at π/6. Those are a distance of π/3 apart. Because if this is π/6 and this is π/6, then together that would be 2 π/6's, which is π/3. So for the asymptotes, you can say x equals -π/6, or you can list off the other one if you want to, plus every interval of π/3 after that. So you would say plus π/3 in, which just means every interval of π/3 after. All right, I hope we learned something today.